Well, good afternoon, everybody. So a few months ago, I put out a video on the Eco-Worthy Cubix 100 Pro server rack battery. And it really has one kind of big feature that I haven't seen any other battery have. And it was designed to allow charging below 32 degrees Fahrenheit, where most lithium iron phosphate cells, once you hit that 32 degrees Fahrenheit, they're designed to stop charging because the cells actually get damaged once you start charging below that. But Eco-Worthy did some stuff to that Cubix 100 Pro. And so the cells they use have a special electrolyte in them, which is designed to allow charging at those lower temperatures, but they also tweaked the BMS so that once it gets below that 32 degrees Fahrenheit, it kind of starts ramping the charging down, where it still allows a little bit of charging current coming in, but it warms up the cells. And I'm not going to rehash the entire review video. If you're interested in it, I'll leave a link in the description and I'll tag it up here. Or is it over here? I can never remember where they put those things. But anyways, in that video, I wasn't able to actually see it ramping down the charging current when I got below 32 degrees. It still allowed charging down to at least 0 degrees Fahrenheit, but it didn't reduce the charging at all. Well, I got an email from Eco-Worthy confirming that they have a firmware update, which is supposed to kind of tweak some settings to allow for that throttling. And also in the last video, as far as I know, the only time that it actually throttled the current was when you had closed loop communication, battery to inverter communication. But this update is supposed to allow the BMS to throttle regardless of closed or open loop. So I want to take a look at getting the firmware updated, and then we're going to run another low temperature test and see, does it actually throttle down like it's supposed to below 32 degrees, but still allowing charging. So let's find out together. So I have had the Eco-Worthy battery running in this Vatra rack for the last several months. And I have had some questions, and I actually do have communication between the Eco-Worthy and these two Techex batteries. I believe they're now Techex now or something like that. They're rebranded. But I can come to the Eco-Worthy, and you can see 3 batteries in communication. So if I hit the third one, 44% state of charge. Battery number 2, 57%. And the Eco-Worthy battery, 68%. So that was just a freebie. Had some questions on it. But yes, it can close loop with some other batteries, I believe, that have the JBD BMS in them. But let's get this thing pulled out of the rack so we can open it up and get the firmware updated. So I got the battery pulled out of the rack, and it should be ready to update all the firmware. And I haven't done this before, so we're going to do this together. So first off, I believe we need to have the battery turned on. The breaker has to get turned on as well in order for the BMS to get turned on. So we'll open the Eco-Worthy app. There's my Bluetooth battery. We're going to tap on that. And as soon as I opened it up, I got a firmware update notification. So we're going to hit update. For safe firmware update, avoid battery damage, ensure the battery is 30% or greater, which we're at 68% right now. Disconnect other batteries. Well, everything's all disconnected. I mean, I do have the wires ready for the charge test later, but it's not connected. I got it. Dip switch needs to be set to 0 or 1. So there we go, 68% state of charge. dip switch is set to 1. So I am on 13.5.4, and the latest version is 14.7.2. So significant jump. So we'll hit download. Well, that was fast. Install. Do not leave the current screen while being upgraded. Please wait patiently at. So some of the language here looks like it could be updated a little bit. After update success, disconnects automatically and then returns to the home page. Okay. So it's sending the update to the battery and then it'll run through its upgrade. So we'll just do a little speed frame here so that you don't have to sit here and watch the ticker scroll. Well, it says installation complete. We went back to the main home screen, so we'll reconnect to the Bluetooth. During the upgrade, we saw the run and the alarm lights blinking, and most of the values on screen went to 0. So now if I go to the gear, firmware update, current firmware version 14.7.2, latest is 14.7.2. And it is the latest version. So nice and simple. I think maybe took 2 minutes, if that, to actually update. So now we just hook a charger up and pop the top, try to do our little cold temp test again and see if it actually throttles that current down once it gets below 32 degrees. So we'll use the ChargeVerter Plus to charge up the battery. And we've got it set to 100 amps of current. Figure, why not? That's what we did last time. So we'll remove the lid. And I already removed all the little tabs for the cover, exposing our temperature sensor. Same sensor we used last time. And let's see here. We are going to throw the details on screen. So we will turn on our ChargeVerter, start putting current in. We can see the current is increasing. There's how much power is going into the battery. Current temperature sensor values, minimum 77, maximum 78. It's kind of toasty down here. So we're at 90 amps right now. And I'm just going to spray our temperature sensor. We should start to see the minimum value dropping. We are going to switch to see the temperature details in the app. Give it another blast. Current did drop down to 9 amps as it got below 32 degrees Fahrenheit, which is perfect. That's exactly what we wanted to see. And if we let it go a little further, in the app, 9 degrees, 6 degrees, 5, 4, 2, 1. We've got an alarm light blinking on the front and a notification showed up in the app. The minimum negative 4 degrees Fahrenheit, but it's coming back up. Let's give it one more blast. It should disconnect at, once it gets past negative 4. There we go, negative 2.9, 3.8, 4.5, 4.9. And we can see our current right there drop down to 0. We look at the app, our minimum temperature is rising. 0.1 degrees Fahrenheit, now we're at 6, and our current went back up. It looks like it spiked for a little bit as soon as it started, and then it's slowly starting to climb as our minimum temperature is getting closer to that 32 degrees. Once we hit 32, I would imagine this current value is going to go back up to full power. There's 30 degrees, 32. Maybe there's a clearance that it has to reach. Maybe it's got to get up to 40 degrees. Well, 42, 44. We're still at 9 amps. 48. There we go. So 50 degrees. So once it hit 50 degrees after being that cold, then it starts climbing back up. Very cool. And as you can see right here, I don't have any communication connected at all. And so let's do that one more time. Make sure that it drops back down to 10 amps once it gets below that 32 degrees. So our minimum temperature in the app, 44. The app seems a little faster. Well, I guess I can't say that. It's kind of jumping all over the place between the app and on screen. But either way, it did drop down below 10 amps of charge current. We can see that 9.4 in the app as well. And then we will let the temperature rise and double check that that 50 degree Fahrenheit is where it seems to release and kind of open the floodgates back up once it's throttled that inbound current at lower temperatures. So we're at 41. So yeah, I'm looking back and forth between the app and the screen. 47, 48, 50 degrees, and it starts its climb back up. Awesome, awesome, awesome. So it's pretty cool to see. So this is the BMS board right here on the left side of the battery. And I believe what they're doing is they're actually utilizing the inductor right there, which is a ring with a bunch of copper wire wound around it. Say that 3 times fast. And they actually use that to throttle the current down to 10 amps. If you end up connecting multiple batteries together that are at different voltages, it'll slowly charge this battery with 10 amps till it kind of balances out. But they're actually utilizing the inductor on the BMS to throttle that current down, which is just cool to see. So it was nice to see that it was really just a firmware update that had to get pushed to the battery. I knew that seeing in the DIY solar forums, they were looking at ways that they could make it work open loop, but I couldn't actually replicate it with the closed loop in the past that was supposed to be working. So they got that fixed with the new firmware push, which is awesome to see. So again, this I could really see being used in a lot of cold temperature places. In fact, I need somebody to remind me when we get closer to winter time. I would like to do an actual outdoor cold temperature test with this, because when winter rolls around, I got plenty of cold temps. So I could easily put this outside in the coop or the shop or something and just let it naturally get cold and acclimate to the cold temperatures, but slap a solar charge controller on it, or even the charge inverter again, and just again see it slowly throttle that current and let the cells warm themselves up instead of having to have heaters that are burning that energy away just to warm up the cells before it can even start charging. So I wouldn't be surprised if we start seeing more batteries like this on the market, but Eco-Worthy's the first one to do it. And when I heard that they put that firmware update out, I just had to test it and make sure that it actually works like it's supposed to. So with that, I'm gonna let y'all go. Y'all stay safe, stay cool, and we'll catch up with you later.